Hello everyone, my name is Andrey Lukyanenko and today I'll talk about doing data science without machine learning based on the projects which I have worked on. These two projects are both about Metro and using data to get some insights about users. First of all, some words about me. After graduating from the university, I have worked for several years as a ERP system consultant. In that part of my career, I didn't know programming and worked as analyst, solving various problems related to ERP systems. During that time, I have worked on multiple projects ranging from logistics and accounting to more difficult things like financing, and learned that a lot of problems can be solved by using simple tools or analytics. And later, I applied this experience while working on data science projects. After several years of working as a ERP consultant, I have decided to switch career to data science. I have studied programming, statistics, machine learning and other things, and it took me nearly 8 months to get a first job as data scientist. Since 2017, I have worked in several companies on many data science projects and, well, many of them had to be solved using machine learning and models work great. But there were also a number of projects which could be done with simple approaches. And currently I am an NLP tech lead in a medical chatbot project in MTSI. Here we have some solutions based on machine learning and some without it. But this is a story for a different time. And the last, but not the least important, is that I actively take part in Kaggle, and you can see here my achievements. I have learned a lot, for example, how to do visualizations and to get insights from them, how to create minimum viable products very fast and with good enough results, well, and many other things. Okay, now, let's move to the contents of the talk. On this slide you can see what I am going to speak about. First of all, I want to talk a bit about why machine learning isn't always necessary and possible. I suppose other talks in our section could mention similar things, but I wanted to share my opinion about it. Next, I'll talk about the first project, describe the task, my attempts to solve it, and share the overview of the solution. What worked, what were the results. And then I'll talk about another project which had less analytics and more visualization, but still could be called a data science project. So let's start. Machine learning isn't always useful. At first, I want to point out that as a Kaggle, I really like machine learning, building both basic and complex models and also solving real-world problems using them. Well, at my current job, I work on solutions using neural nets, but still. Still, it is necessary to understand that in the end, machine learning is a tool. It is an amazing tool, but still a tool which is used to solve certain problems. And when you are solving real problems at job, it's crucial to choose the right tool, and machine learning isn't always the best one. Sometimes you don't have enough data. For example, this could happen when you only start collecting the data, or you want to solve some new problem, or do something in a new domain. Imagine we want to do an NLP for some exotic language, but it's totally possible that there are no pre-trained embeddings or even datasets. It could be better to start with some simple solutions or approaches. On the other hand, it's ironic, but you could have too much data. This is problematic if there is no infrastructure, some security barriers, or if you have weak hardware. Imagine, some company started collecting the data, they bought a Hadoop cluster, collected terabytes of data, then hired a first data scientist and gave him a laptop with 4 GB of RAM. Well, it will be much more efficient to use SQL and do analytics. Now, let's imagine you are working on a good machine learning task, text classification, tabular classification, or something else. But you don't have enough labeled data. Of course, there are ways to solve this problem. You can label the data by yourself. You can find some labeled data and do pseudo-labeling. Also, you could do active learning or other cool things. But this takes valuable time. Making something simple based on statistics could work well enough and it will be fast. Sometimes, when you have a lot of unlabeled data, you could do clustering. But clustering in my practice often is used to confirm some ideas generated by managers. Of course, there are cases when it works. For example, topic modeling or finding new groups of users for targeting and so on. But they usually require a lot of efforts to interpret and understand the clusters and to project them on the real world. Also, sometimes baselines can work well enough. This is especially true for time series. If you calculate some simple moving average, it's totally possible that you'll spend a lot of time trying to do something better with machine learning and you may even fail. Next point is that data science isn't only about models. Analytics, dashboards, and visualizations are important parts of data science. And understanding business is really important because domain knowledge can lead to better and simpler solutions. And sometimes rule-based solutions work quite well until you need to handle too many scenarios, and still a lot of chatbots use rule-based solutions to switch between intents. Now let's move to the project I am going to talk about. Imagine there is some metro. Well, it doesn't matter in which country. There is Wi-Fi, which works on stations, not on tunnels. This is important. And you have collected some logs with the data. There is a lot of the data, and now you want to use it. You hire some company with a relevant experience and ask them to do something with the data. You can segment users into groups. Also, you could find some characteristics of the users, show them the relevant ads, and get profits. Now, suppose our first task is to find out where people live and work. Considering we have information logs only for stations, we can only say near which stations people live or work. But this could already be enough for geo-targeting ads. Let's see which data do we have. First of all, of course, logs from the database. Logs have a lot of information, but relevant columns for our task are only timestamp, user ID, and station name. Usually, there are a lot of lines of logs for one visit of a station by one user. Of course, there are no labels. One of possible approaches would be to ask users to log into Wi-Fi using some other site, unless we didn't have such a possibility. Okay, so we don't have labels. And even if we had them, it would still be difficult to train a model on such data and target. One additional problem is that database size is limited, and we have data about a couple of months, for example. Okay, that's general data. What additional data could be useful? First of all, it would be great to get real coordinates of the stations, so we could understand how are they placed on map. Some of the data was provided by the metro company, but it wasn't full enough. It was funny, but I got better data by going to Wikipedia and manually copying data from pages about these metro stations. What else? I'll talk in details about this later, but it could be really useful to know the travel time between the stations. Of course, we could derive travel time from coordinates, but it wouldn't be very precise. I was able to find a small site which contained travel time between each pair of stations, so I copied the data, reformatted it, and checked that it was reasonable and used it. That's for our data. I'll talk about ideas and approaches which we tried. We proceed from the assumption that people use Wi-Fi on each station they visit, as we can do nothing if they don't use Wi-Fi. The first idea usually is visualizing the data. I used volume and plotted how several people traveled on some days. It was cool and nice, but wasn't really useful. Okay, let's try to analyze station visits. We can calculate a lot of things. How often certain stations are visited, try to find patterns of visits on different days of week, different hours of the day, and so on. Also, it's important to find real station visits. As I have already said, there are many rows for each visit of a station because people do a lot of things on the internet. And we can't just combine all the consecutive logs on a station, because user could log into Wi-Fi on a station, leave the metro, and come back to the same station after some time. So we need to be careful. Okay, let's analyze the routes. It means how people moved within a day. I tried it, and it really no, and the results were more understandable. But you see, most of people move a lot within a day. At the bare minimum, people travel to drop and back. But some people could travel to many places within a day, for example, to a pub after drop. So let's try to distinguish real roads. When a person went to metro, traveled, and left the metro. First of all, it's always important to remember the goal. In our case, it's finding home and work stations. So we need the roads with these stations. Let's think. Usually on weekdays, people start their road from home and live and work. Then in the evening, they travel back. On the weekend, people usually start and finish traveling on their home stations. Also, usually they don't work on weekends. There could be a lot of problems with these assumptions. Some people could work night shifts, some people could have an irregular working week, and so on. But in the first version of the project, we decided to work with more usual cases and work with others later. Still, there are more possible problems. Let's think, what's the definition of the road? Log in on one station, log in on several consecutive stations, and stop logging at a certain station. What is the time difference between stations is high. Then I suppose a person left the metro, right? At first I used some fixed thresholds for this time difference, but then I have found the aforementioned data with travel time between stations and made a rule that if travel time exceeds the expected time by some multiplier, then the route was finished. This really helped. One more layer of complexity is that some stations are near each other, and the person could start or end travel on any of them. I created the idea of clusters, defining home or work stations as 2 or more nearby stations if they were within a radius of 2 kilometers. 2 kilometers was an arbitrary number based on my analysis. And the last interesting problem, there were people who logged on a single station. They didn't log in any other station. Maybe these people worked at these stations, like a place of work? I'm not sure. So these were my general ideas and general approaches which I tried. So what was used to create a solution? As I said, at first we derive real roads. So I mean, we drop duplicate stations, we find cases when people stop traveling and so on. So we take these real roads, split them into morning and evening roads, also into weekday and weekend roads. Take the most common of them and take home and work stations based on them. As I said, that people start traveling from home at the beginning of the workday and so on. And at the end we calculate the number of visits of different stations. Then there were a lot of filtering and if-else in my code. Well, it really worked. For example, I compared number of visits of different possible stations for home and for work. I tried to find these clusters of stations. I separately analyzed users who visited a single station. Also, I was asked to calculate some confidence of my predictions. It was a complex formula, but the main idea was about taking the number of visits of the station, the number of visits of other possible stations, and dividing them. Also taking the number of roads with the most possible station and dividing it by the number of roads of other possible stations and multiplying these numbers. After the code of the algorithm was finished, we asked for some validation data. The company sent us the logs with people who worked in the company, so we had labels. The accuracy of my approach was 60%, and the errors happened only because there wasn't enough information about some users. Some people switched home, some people switched their work, and in general the database was small, as I said it before. So we thought that the result was pretty good. That's it about the first project. Now I want to talk briefly about the second project, which was less about analytics and more about visualization. We wanted to show the visualization of Moscow metro based on the company's data. As an example, I was shown this cool 3D visualization of Moscow metro. I was impressed and shocked because I didn't know JavaScript well enough to do something like that. So I started researching what I could do. First of all, I needed the data. Of course, it's not possible to do anything without the data. So I took data from Headhunter and Yandex.API to get information about roads, stations, coordinates, and so on. I took data from our database, like statistics about stations, and then I started choosing the tools. At first, I have found some cool visualization in R, but I had little experience with it, so it was very difficult to change the things, and I switched to Python. I started with Bokeh, and here you can see my first attempts at visualization. Yes, it's not very impressive, I understand. Next, I moved to Plotly. It got better, but well, still, I suppose not really cool, but sorry, I'm not designer, I have little experience with such things. If we talk about technical details, then the data was converted into network X graphs. The data about stations was assigned to nodes and entries, and I used Plotly to solve this graph. As you can see, I even made a three-dimensional version of it. Also, I made some fun thing like possibility to find the shortest road between the two stations, but said I can't show it here as the project is long finished. What could be shown on these visualizations? Anything. We could show number of users, the aggregated statistics, some events, some types of users, some things which they use, and so on. And we could use color, node size, vertical positions to show this data. So that's it for my presentation. I have talked about the cases when machine learning isn't necessary in data science projects, talked about two of such projects, and while the second one didn't really help with any business task, the first one could be really used for getting insights about users and getting profit based on them. Thanks for listening to me. On the last slide you can see my contacts. Thanks and goodbye.